And thank you. Warm welcome to all of you joining in wherever you are around the world. My name is Roel Seibing, Senior Trainer for ATLAS.ti, welcoming you to this ongoing webinar series with ATLAS.ti and the International Qualitative Research Network. We have a wonderful topic and a wonderful presenter for you today. And to introduce our presenter, I'm going to hand it to my colleague at the University of British Columbia, Eric Lee.
Thank you so much, Mark, for that. Good day, everyone. So I'm joining you from the co-occurrence nation in British Columbia, in Canada, for that. So today it is with our honor to have Professor Majid Ghasemy is presenting the topics of exploring multi-level theory development with ATLAS.ti. So maybe before I introduce the speakers or invite the speaker to join us, but I would like to give everyone a background information about the International Qualitative Research Network. This is a network of qualitative research leaders from around the world. So it's based in the School of Nursing at the Universities of British Columbia, Okanagan campus. So the purpose of IQRT's or International Qualitative Research Network is to build qualitative research capacity with the emphasis on local scholars who live, studies, work in developing countries. So the primary strategies of achieving this purpose of webinars and workshop like today. So recording of our webinar, like Rob says, but that will be all available to all the scholars all over the world for free. So this is our purpose to really kind of by sharing our knowledge and insights on qualitative research with many others. So having said that, I would like to provide a little bit more information about Professor Majid. Professor Majid is a senior lecturer at the National Higher Education Research Institute at University Sains in Malaysia. So he's held various significant roles, including being a former coordinator of the Global Higher Education Network, Malaysia's and the mentors for the Web of Science Academy. So he also holds distinctions being a certified ATLAS.ti professional senior trainers and also recognized as the solo EQS or EQSIRT consultant globally for that. So without further ado for that, I would like to invite Professor Ghasemy to join us today. Thank you.
Okay, Eric, thank you very much. Hello, everybody, and welcome to this webinar. So today, we're going to talk about multi-level theory development using ATLAS.ti. So this is the outline of the content that I'm going to cover. I'm going to cover. So we start with some basics of theory and its relation with research approaches. Then we continue with discussing about single level versus multi-level theoretical models. Then we focus on multi-level mediation models, which are in fact a kind of extension of multi-level models, a very interesting extension of multi-level models, in fact. Then I briefly talked to you about grounded theory and its role in multi-level theory development. Of course, we don't go into details, but we just very briefly, I will talk about grounded theory design. And then I will share with you some basic information about code-Cooccurrence table and why we can, and what are its capacities and how we can use those capacities to build multi-level models. And then I will demonstrate an application, which is in fact a kind of made-up application, because I wanted to create a good example for today's discussion. That's why it's not based on real collected data. So it's a made-up application, but it can serve as a very good example to understand the issues that I will discuss with you. And then we will have some concluding remarks. So before I start the presentation, I just would like to highlight the fact that among the participants, we have different people. Some of them are my esteemed colleagues from different universities. Some might be master or bachelor students or PhD candidates. So some contents might be a little bit easy or simple for some of the people. And since we have a mix of people from different educational levels and qualifications, that's why I had to include those basic concepts into this presentation to make it appropriate for our audience. All right. So, as you already know, we have three types of research approaches. We have qualitative research, quantitative research, and mixed method research. And normally, the objective of these different research approaches are different when it comes to the application of theories. In fact, in qualitative research, normally what researchers do is that they try to generate or build a new theory that can explain the relationships between different concepts. Or sometimes in qualitative research, you can use theory to guide you and to make you keep on right track when you are doing your research. So this is mainly the role of theory in qualitative research. So in fact, what we do in qualitative research is that we develop theory. So this is the main issue. With respect to quantitative research, what we do is that we normally test and verify some existing theories. And in the context of mixed method research, what we can do is that we can build a theory, and at the same time we can test and verify that theory. So you can see that theory plays a very important role no matter what research approach you adopt to conduct your research. Now that we understand that theory is very important, let's have a quick look at some theories and or the definition of a theory. So in fact, theory is just a combination of some variables and the relationship between these variables. So how these variables interact with one another is in fact explained by a theory. And I have provided one example here. So this is the figurative summary of affective events theory, which is one of the major theories in the context of industrial and organizational psychology. And as you can see, we have some variables that are displayed in boxes and some arrows between some variables. And basically, these arrows, in fact, can tell us how these variables are related to one another. So here we have 6 variables in these blue boxes, and these are in fact, the hypotheses that can help us understand how these variables are related to one another. For example, focusing on this part of the theory, you can see that work environment features influence affective work events. So the theory is just a combination of variables and how these variables are related to one another. Please note that in the context of qualitative research, normally we are dealing with codes and themes, and codes and themes are in fact translated to variables or constructs in the context of quantitative research. So some parts of my presentation might be a little bit more towards quantitative research, but I will explain it in a kind of non-technical language so that those who are involved in qualitative research can easily understand my discussions. Now that we understand that theories are just a combination of variables and how they are related to one another, I think before we delve into our discussions, it's important for us to understand different types of variables that can build a theory or a theoretical model. So the first type of variables in any theories might be predictor variables. And if you study different research methodology references, you can see that these variables are called with different terms. For example, antecedent variables, independent variables, treatment variables, manipulated variables, and also in the context of econometrics, they are called exogenous variables. So these variables are variables that predict or influence other variables. That's why we call them predictors. The second group of variables that are used to build theories are outcome variables. And again, similar to predictor variables, you might find different names for them in different resources, such as criterion variable, response variables, dependent variables, and endogenous variables. So outcome variables are in fact the outcome of predictors, or in other words, they are predicted or explained by the predictor variables. Then we have mediating or intervening variables. And basically, these are the variables that can transmit the effect of predictors to the outcome variables in any theoretical model or in any theories. Or in fact, in other words, they play the role of predictors and outcome variables at the same time. And then finally, we have moderating variables that are in fact categorized under predictor variables. So they are in nature predictive or predictor variables. And what they do is that they affect the direction or the strength of the relationship between different variables. So predictors, outcomes, mediators, and moderators are the variables that are widely used in developing theories. And let's have a look at a figurative summary of affective events theory. In this figure, as you can see, I have shown which variable plays which role. So here you can see that we have one predictor variable, which is work environment feature. It is a predictor variable because it is influencing affective work events. Note that we have a moderator variable, which, as I told you, serves as a, it can be categorized as a predictor variable, and it influences the relationship between two other variables. So here you can see that personality traits influences the relationship between affective work events and emotional reactions. We also have two outcome variables, and they are outcome variables because they are predicted or influenced by this variable. And finally, we have two mediators or two mediating variables, and you can see them in green color. So you can see that, for example, the effect of this predictor is transmitted through these two green variables to job satisfaction or to job performance. So these two are mediating variables. And remember, in quantitative research, you can test the entire theory or a part of the theory. So basically, in quantitative research, as I mentioned, we are interested in testing theories and or a part of that theory. Also note that these relationships, as I mentioned in previous slide, are in fact a hypothesis that can be tested. So normally in quantitative research, if we want to test this theory, we just need to collect data for these variables and just do some statistical analysis to test all of these hypotheses. Now let's have a look at theories, single level theories versus multi-level theories or theoretical models. I have provided you with one example here. So here in this part of the slide, you can see one model which has two predictors and two outcome variables. So it's a theoretical model, and you can see the four hypotheses here that define how these variables influence these two outcomes. And if we want, let's assume that we would like to test this theory based on the data we collect from lecturers. So we have to give a questionnaire to the lecturers and ask them to answer some questions about these four variables. Then we can do some statistical analysis to test this model and also to test these, in fact, to test these hypotheses. But the problem with these single level models is that where you have collected data from one group of people is that it might happen that some of these lecturers come from the same department. So they share the same head of department, they share the same working place. And basically, in testing this model in the context of quantitative research, what happens is that we essentially violate some statistical assumptions, and perhaps the most important one is the independence of observations. So we cannot, when we don't consider the fact that some of these lecturers might come from the same department, in fact we are violating the assumption of independence of observations, because in fact those who come from the same department might not really be assumed to be really independent from one another, because as I mentioned, they share, for example, the same head of department, the same workplace, etc. Now, if we know that which lecturers come from which department, we can have the same model at two levels. We can have that particular single level model at lecturer level and also at department level. So having the information about which lecturer comes from which department can enable us to specify or to change this single level model into a multi-level model and test the model at two levels. And if we manage to do so, there is no problem with respect to independence of observations. And in fact, our estimates, the values that we have based on our analysis, in fact, are more efficient and more accurate. So this is the philosophy behind multi-level theory development, multi-level theory testing. Of course, after that, I will go to multi-level theory development, but it was essential and necessary for me to explain this for you. So this is the philosophy behind that. And by having a multi-level theoretical model, we can address the hierarchical or clustered or nested nature of our data. So in general, estimating in the context of quantitative research, estimating multi-level theoretical models or testing multi-level theoretical models is a kind of a more accurate approach in testing models. So if you just want to have some more information about this model, you can refer to this publication, which is one of my recent publications. And basically you can see how how different these models might be at lecturer and department level. Now, one of the nice extensions of multi-level models are multi-level mediation models. So before I explain this, even though you already know what a mediator variable is, and I explained it a little bit briefly in the previous slides, but anyways, let me just explain it a little bit in more details. So first, before we focus on multi-level mediation models, which I told you is the extension of, is one of the interesting extensions of multi-level theory development, let's just focus on single level mediation. So this is a single level mediation. As I mentioned in the previous slide, we have a predictor, we have an outcome variable, and we have one mediator. So eta2 is the mediator in this model, and what it does is that it can transmit some part of the influence or impact of eta1 on eta3. So we will have a direct effect from eta1 to eta3, and also we can have an indirect effect through eta2 for the influence of eta1 on eta3. Now, this is a simple single level mediation model, but if we want to focus on multi-level mediation models, basically there are different types of multi-level mediation models, but the two popular models are 2-1-1 models and 2-2-1 models and 2-2-1 models. I have provided you with a figure which shows how a 2-1-1 and how a 2-2 model might look like. And basically the label of 2-1-1 indicates that the first predictor, the predictor variable is at level 2. So you can see we have two levels here. So the predictor is at level 2, the mediator is at level 1, and the outcome is at level 1 as well. Whereas in a 2-2 model, we have the predictor and the mediating variable at level 2 and the outcome variable at level 3. So these are the commonly used multi-level mediation models. And what they can do for us is that we can examine mediation processes at different levels. Here in the single level model, you can only test this model at one level, but here you can see that we can in fact focus on two levels and see how the mediation operates at different levels. Also note that these type of models could be cross-sectional or longitudinal. And I believe you already know that cross-sectional studies are studies in which we normally collect data at one point of time. So for the predictor, outcome, and the mediator and the outcome, we collect data at one point in time. But for longitudinal studies, what we do is that we collect data over time for different variables. So for example, we can collect data for eta 1 at time 1, for eta 2 at time 2, and for eta 3 at time 3. So basically, you can estimate cross-sectional and longitudinal multi-level mediation models when it comes to quantitative research. Also, note that we can um, investigate how variables operate within each level and between each level. So here you can see that, for example, within this level 1, we have one mediator and one outcome variable. And here we have the predictor and the mediating variable at level 2. And another point with respect to these models is that um, uh, we can have a within level and between level mediation. So this is something that I'm going to show you in the next slide, which is one of the most complex models I have ever seen in different I mean in published papers, in published papers. And basically this is a very nice model. Let me just go back here. I told you that you can have within level or between level mediation models when you are focusing on multi-level mediation models. So in this model, you can see that the researchers have collected data for different variables at 4 time points. So it's a longitudinal model. Also, you can see that we have individual level or level 1 and average leader level or level 2. So you can see that it's a multi-level longitudinal model. And here you can see that, for example, we have a mediation, we have a within level mediation model here. So from work experience to technology, self-efficacy to use of technology, and also to post performance, you can see that we have a series of mediators, and in fact we have a within level mediation. We also have a between level mediation. For example, look at the task running from leader commitment to use of technology, so from level 2 to level 1, and to post performance. So it's in fact a 2-1-1 model. So this is one example of a multi-level mediation model in the context of quantitative research. So now that we have learned how multi-level mediation models look like in the context of quantitative research, let's just go back to qualitative research and see how we can help quantitative researchers with providing them with a multi-level mediation model that is purely driven, that is purely data driven. So to develop a model in the context of qualitative research, as you already know, we normally focus on grounded theory approach, grounded theory design. And if you are just familiar with this research design, you already know that it involves iterative real data collection and analysis, and this process leads to the development of a new process, a new theory. And basically, there are 3 main steps in the grounded theory research design. We start with open coding, we continue with actual coding, and then we finish our job by selective coding. But I don't want to go into details about these two. I just want to highlight some facts about actual coding and how it can be used to build more complex multi-level mediation models. So look at here, axial coding method begins to organize codes into broader categories for qualitative analysis. So in fact, you can have some categories for your themes. You can have maybe some sub-teams, you can have some sub-teams, or for codes and subcodes, so you can have subcodes under one code. And this can simply be translated into the context of quantitative research. So we can have higher order multi-level mediation models as a result of axial coding in the context of qualitative research. So for example, here you can see that based on the results of axial coding, we have, this is just of course one example, you can see that we have two categories or two sub-themes for this theme or for this code. And if you remember in the previous slides, I indicated that codes or themes in the context of qualitative research are translated to variables or constructs in the context of quantitative research. So if you do axial coding, when you are doing grounded research, grounded theory research, you will be able to have higher order you will be able to build or develop higher order multi-level mediation models. So here you can see that we have 2 dimensions for the predictor. Here you can see that we have 2 dimensions for the mediator in a 2-1-1 and a 2-2-1 model. So this is just one thing that I wanted to highlight, that I think it's quite important. Now, I would like to highlight another point. You know, in quantitative research, I told you that we normally test theories. So we have to build a kind of a theoretical model and then test it. So we have to collect data for different variables and then test different hypotheses. All right. This is one example. It's a multi-level model we have collected. If you want to develop this in the context of quantitative research, basically you need to collect data for all of these variables from different groups of people. So for these variables, for example, you have to collect data from students. And for these variables, you can collect data from lecturers. And also note that the relationship between these variables, all of these passes are should be in a quantitative research, should be underpinned by theoretical foundations or empirical grounds. In other words, in quantitative research, when a researcher would like to build this model and then test it, what they do is that they do a literature review for all of the variables here, and then based on literature review and also based on some theoretical grounds, they can specify these passes between different variables, and they can test this model. So this is in the context of quantitative research. However, we can have the same model in a qualitative research. For example, a quantitative researcher can come to us and ask us to, for example, build a multi-level mediation model, and then we can build that, and then we can give it give this model to the quantitative researcher to test it for us. So we can, as you can see, we have almost the same structure in the context of qualitative research. You can see that we have lecturer affect, we have lecturer motivation, a student affect, a student motivation, and a student retention. These are the variables or the codes, or in the context of quantitative research, the variables that we have in this particular hypothetical research scenario. So we can simply develop this model, but the difference between this model and the model I showed you in the previous slide in the context of quantitative research is that now here everything is underpinned by our collected data. So all of the relationships between these variables have been based on the data that we have collected, for example, through our interviews or observations or whatever data collection method that you have. So this will be the equivalent model to the one in the previous slide, but in the context of qualitative research. And what I want to do, what I want to do today is that I would like to show you how you can come up with this model in the context of qualitative research. So if you are doing a pure qualitative research, you can develop this model and you are done in your qualitative research. You manage to develop one theory. Or if you are working with other quantitative researchers, you can build this model and then you can ask them to collect data for different variables that you have in this model and ask them to test this model for you to see whether what you found in the qualitative research actually works in the context of quantitative research or not. So this is what we are going to build today. And now, before I show you how that model can be built in the context of qualitative research, let me just briefly introduce the code-co-occurrence table to you. So basically, this is just a simple table, but it has a very important and nice feature. In fact, this table can help us identify all of the codes that have been applied to the same quotation or to the overlapping quotations. Of course, when we would like to build a theoretical model that explains how variables are related to one another, normally we are not interested in this part. So we just focus on the codes that have been applied to the same quotations. And basically, there is a nice feature in ATLAS.ti, and if you enable that feature, only the codes, I mean, in the results of the analysis, you can only get the quotations that have been coded, the quotations that have been coded with, for example, the pair of codes. So when we are working with code-co-occurrence table, we have to, and we would like to build a theoretical model, especially a multi-level theoretical model. We have to consider selecting this option, use AND operator. So never forget that. Also, there is another option which is cluster quotations. So basically, you don't need to do this, because if you activate this option, what happens is that the embedded quotations will be counted only once. And this analysis is based on the counts, or based on the hits, based on the number of quotations that have been coded with two codes. So if you activate this option, in fact, the results might not be accurate. Another interesting feature of code-co-occurrence table is that it can show a coefficient which is called C coefficient. This coefficient is between 0 and 1, and it indicates the strength of the relation between two codes. So in terms of interpretation of this code, you should be quite careful, especially when you see some colored dots in the cells of the code-co-occurrence table. If you refer to the manual of the software, I have provided one of the issues that you need to consider here. I'm not going into details about that, but remember, if you find any colored dots in the cells of code-co-occurrence table, you should be very careful, and you should certainly refer to the manual of the software for the interpretation of the C coefficient in that particular cell. So this table, if I want to conclude about this code-co-occurrence table, I can tell you that this table can offer insights into the patterns and relationships at multiple levels of analysis, and you can also visualize these patterns using the network tool and come up with this particular multi-level model. So this model is in fact the result of code-co-occurrence table and the network tool in ATLAS.ti. So we always visualize the patterns of the relationships using the network tool, and this is what we will do right now. So let me just go to my ATLAS.ti. I would like to show you the illustrative application. Okay, so this is my ATLAS.ti. I believe I shared my entire screen. So Eric, you can see my ATLAS.ti, right?
Yes, we do.
All right, thank you so much. So this is the made up example that I have created for this presentation. Let me just open it. All right, before I explain everything about Code-Cooccurrence table, let me, for those who are not familiar with ATLAS.ti, let me briefly explore the software for you. You have different ribbons here, and if you click on any of these tabs, you can see the content of these ribbons. So focusing on the home, you can see that we have managers here, and also the Explorer panel. Normally, the data elements are displayed in the Explorer panel. So if you have documents, codes, memos, or networks, you can explore all of them here. And also, if you have if you create document groups, code groups, memo groups, network groups, again you can see all of them here. So the Explorer is a very nice feature because you can simply use this to explore your project. Also, note that if you would like to manage your documents, you can simply click on this documents option, which opens document manager. If you would like to manage your codes, you can simply click on codes. If you want to focus on code groups, you can click on this option. For the memos and networks and links, we also have the same situation. So basically, managing different data elements can happen here. So you can use these options here. Also, when it comes to coding, there are a lot of interesting features here to create codes in ATLAS.ti. So you can do AI coding. You can just do sentiment analysis. You can do named entity recognition, coding, and basically you can search the text and do some coding. So there are different approaches to coding. I don't want to go into details. Then we have the analyze button, where you have these important features. You have code-cooccurrence analysis. This is what we're going to focus. Then we have code document analysis, which is another interesting table in ATLAS.ti, which can help you to develop theories that can be used to explain the differences between groups in terms of different codes or themes. So if the theory that you are going to develop is about the relationship between variables, you can focus on code-cooccurrence table. If your theory is about explaining the differences between different groups in terms of one or a few codes or themes, you have to consider using code document analysis. Also, if you would like to deeply focus on the quotations in your projects, the important segments of information in your project, in different documents, you can use the query tool. You can define different queries, and you can retrieve different sets of quotations that can satisfy your queries. Also, another nice feature of ATLAS.ti is that you can import information from a wide range of applications into ATLAS.ti for the purpose of coding. For example, if you would like to import tweets from Twitter to ATLAS.ti and do some coding on Twitter, on tweets, you can simply click on this option. If you have some notes in your Evernote software, you can import them into ATLAS.ti. If you would like to import some articles from your reference manager, you can consider this option. And also, you can export some information from your project into an Excel file, or maybe into SPSS using these options. And finally, we have tools, and basically here you can manage the users who are doing the coding and doing the analysis and all of these stuff. And then you have the help with a link to the YouTube channel. Certainly, it is one of the most important buttons in the application, in this software, because many video tutorials are accessible in the YouTube channel of ATLAS.ti, and you can simply watch those videos and learn how ATLAS.ti works. Now, if you look at my project, you can see that I have 5 documents. All of them are in PDF format. Of course, I told you it's a made up example, so I don't have any interviews or anything to show you here. So I just used some articles as the documents and did some fictional codings, so that I have a set of codes and also quotations being coded with these codes. So I have 5 documents here, and as you can see, the number of quotations within each document is displayed in front of the document. So there are 24 quotations, for example, in this document. As you can see, all of the quotations are numbered. We have, and as another example, we have 41 quotations in document D5. Also, with respect to the codes, we have 10 codes in this project, and there are 2 values in front of them. The first one is the groundedness, meaning to say how many quotations have been coded with this code. So for example, leader effect, we have 48 quotations in the entire project being coded with this code. Or for example, for leader performance, we have only 9 quotations. The second value that right now you can see all of them are 0 are in fact the density values. So these values refer to the relationships between the links between these codes and the other codes that we have created in this project. Right now, we don't have any codes being linked with other codes. That's why you can see that all of these values are set to 0. So the moment that we link the codes in a network, for example, you would see that these values will change. Now, to open code-co-occurrence table, I just need to click on co-occurrence analysis. And here you can see that I have the list of all of the codes here for the columns, and also the codes that can be used as the rows. So I just click on these boxes because I want all of the codes to be displayed. Then I click on this option, show list, so that this panel is removed from my screen. Let me also drag this to the left, and also this one to the right. Okay, so you can see that I have all of those 10 codes here. You can also see that I have the number of quotations being coded with any of these codes. And here you can see a matrix which contains some values. Please note that whatever you see below this diagonal is exactly the same as what you can see above this diagonal. So we normally focus on one segment of this table, either below the diagonal or above the diagonal. There are also some options here. Let me just click on that. I told you that to do a proper multi-level mediation model development, you have to consider using the AND operator to ensure that the number of the quotations that are displayed, the number of the hits that are displayed in this table represents the number of quotations being coded with the 2 codes. So I just click on this, and then you can see that some of the values are changing. And now what you can see is that, for example, focusing on this cell, you can see that we have 15 codes. We have 15 quotations coded with leader affect and also leader motivation. And I only need maybe 2 or 3 minutes to finish everything. I don't know what this sound is for, but I mean, I think in 2 or 3 minutes I will finish. So anyways, this is the number of the hits, the number of quotations being coded with these two codes. Also note that here you can see the number of the quotations. So 48 quotations for coded with leader affect, and also 34 quotations coded with leader motivation. Also in the parentheses, you can see the C coefficient. So when the bigger the value, the stronger the relationship between the two codes. So here you can see that it is 0.22. For this one, it is 0.05, because we only have two quotations that have been coded with these two codes. That's why the relationship, this coefficient, is small. But here, for example, it is 0.22 because we have 16 quotations coded with these two. So also note that the cells which contain higher values look darker. Of course, you can change the colors if you want, but I just selected the green color for them for the entire table. So what you can see, what you can infer from this table is that there are some strong relationships between some codes. For example, leader motivation with leader affect, leader motivation, leader affect with leader motivation, or leader affect with a student affect, or leader affect with a student satisfaction. Also note that when I click on any of these cells, the number of the quotations are also displayed in this panel, but it's not the focus of my presentation, so I'm not going to explain that part for you. But if you click on any of the cells, note that the quotations are displayed on the right hand side. Now, if you look at this table, you can see that there are some values that are quite high. For example, this one, this one, this one, this one, this one, this one, and this one. So these are in fact, indicate the strong relationships between some of the codes. So I'm going to select these codes because for example, look at here, leader affect and also leader motivation, because they have a strong relationship. So I'm going to select these codes with a strong, with high number of quotations, and then I will create a network and just connect them to create my multi-level model. But remember, connecting those codes with one another requires a strong evidence in your data. You cannot simply connect whatever you see here with one another to build a model. So there should be a strong evidence in the data that you have collected to link different codes. So to create a model based on this information, I just go to home and I select new entities and then select new network. And I just give this name to this multi-level mediation model. And then I click on create. And now you can see that next to the code co-occurrence table, I have this network. So I'm going to drag all of these all of these codes into the canvas here. So the codes of interest will be lecturer affect and lecturer motivation because of this value. So I just go here, I go to the list of the codes, and I select lecturer affect, drag and drop it here, and also the second one, which was lecturer motivation. So lecturer motivation here. And because these are based on the data I collected from the lectures, so that's why you can see that I have used L in front of them. So this is the quotations coded with this code are the codes related to the concept of affect, and the data have been collected from lecturers. So for example, for this one, the code S commitment is connected to all of the quotations which are related to the commitment of students. So that's why you can see the S in front of those codes as well. Now, how about the next one? Lecturer affect and a student affect. So I have lecturer affect here, so I'm going to add a student affect. to the canvas. Then we have lecturer affect and student satisfaction. So I have lecturer affect here, and the student satisfaction is also here. So I just add it here. And next is lecturer motivation and student retention. So I have lecturer motivation, and the only one is student retention. I just add it here. And then we have a student affect and the student satisfaction. We already have both of them in the canvas. And the last one is a student retention and a student satisfaction. And I told you we have all of them in the canvas. Now, if we have a strong evidence to in our data, in the data that we have here, to support any relationships between them, we can simply connect these with one another. So to connect, let's assuming that we have a strong evidence in our data to link these with one another, we can simply select and connect these codes with one another. So when you connect them, ATLAS.ti gives you a lot of options how these codes are connected with one another. And in our case, we are assuming that in our data, we have evidence for the causal relationships between these variables. So I just select is a cause of, and now you can see that I have defined one relationship between these two codes. We can have the same situation for all the other codes in this picture. So let me just quickly connect them, assuming that there is evidence in our data for these causal relationships. If there is no strong evidence for this, then you cannot actually connect these codes with one another. And this way, you can simply create a multi-level mediation model. You can see that it is a multi-level model because we collected data from lecturers and also students. I have also changed the colors of the code so that you can easily see that. And all of these relationships come from the evidence that we have in all of these quotations. But I told you this is a made-up example, so we are assuming that there are strong evidence to support these relationships. Also, I can request ATLAS.ti to show the density and groundedness of these codes that are translated to variables or constructs in the context of quantitative research. So you can see that there are 48 quotations coded with this code, and there are 3 links between this code and other codes. So this is one of the links, this is another link, and this is another link. So this value is 3. Here, oh, sorry, I forgot to add these 2. All right. So here, for example, for a student retention, the density value is 2 because there are 2 relationships or 2 links with other codes. So this is how you can simply come up with this model. You can simply create this model in ATLAS.ti using a combination of code-co-occurrence table to identify the pattern of the relationships and to visualize this relationship using the network tool. All right. This is my last slide. So as a concluding remark, what I want to indicate here is that if you become proficient in analyzing multi-level mediation models, it can significantly enhance your research capabilities because mediation models are very important and interesting for quantitative and qualitative researchers because they can show the mechanism through which some effects are transmitted from one variable to other variables. So basically, they are very popular models. And number 2 is that by incorporating multi-level mediation analysis into your research practice, you will be able to uncover complex relationships and gain deeper insights into your research questions. So the type of research questions that you can answer when you are developing a multi-level model or you test a multi-level model as a quantitative researcher in fact will be more complex, because you are looking at different levels. You are not just focusing on one level. All right, thank you very much. I'm sorry, I think my presentation took almost 15 minutes rather than 45 minutes, so I'm very sorry for this. Thank you very much.
Not at all. Very informative presentation. So really appreciate you taking the time. Yes, please feel free to react with applause and whatnot. And thank you. If you can stop the screen share so we can have a face-to-face present. So maybe if you have any questions, please feel free to post in the Q&A section, which is the speech bubble with the question mark. One question that I have is, actually, we do have a question from a Matthew Hill. Can you discuss strategies for co-occurrence coding with your data?
Strategies to code to what? Sorry.
So the question, can you discuss strategies for co-occurrence coding with your data? So maybe if you are trying to identify co-occurrences for the purpose of theory development,
Okay.
how do you go about coding the data first off?
All right. I think one important point to consider when you would like to develop a multi-level model is that even though in code-co-occurrence table you can identify overlapping quotations, meaning to say that some parts of the quotations overlap, and you can simply identify them in the context using the ATLAS, using the code-co-occurrence table in ATLAS.ti. But basically, they are not effective. I mean, they are not important, because they cannot help us to build a good theory. In fact, we need we need quotations that have been coded exactly, the entire quotations coded with two codes, to infer a relationship between those two codes. So I think one strategy, if we can call it a strategy, is that we just try to identify those quotations that can simply be coded with two codes. I mean the entire codes. Also note that sometimes we might have one quotation, but one big quotations with some embedded quotations inside. And if this is the case, we should never forget to deactivate or not selecting the cluster quotations options, because if we do so, again, it causes some error in our interpretation of the results of code-co-occurrence table, and this might lead to some inaccuracies in terms of developing our theory. I hope I answered the question, but if not, maybe you can clarify, and then I try to explain again.
No, I think that works, especially with the Code-Cooccurrence tool in ATLAS.ti. Yes, they have to occupy the same quotation. Two codes have to occupy the same quotation. And then there's different settings in the co-occurrence tool. We invite you to play around with the co-occurrence tool, test it out on a small segment of data, so you can see how the table works. But once you understand how co-occurrences are identified, it's a pretty powerful tool to help identify relationships between codes. There's a couple questions, and we are getting close to the top of the hour, so I'm going to so last chance for questions, but we'll continue to answer the existing questions until we go through all of them, if that's okay with our presenter.
Of course, no problem.
Absolutely. Matthew Hill follows up on his question with, I think you need a clear strategy for your coding up front before you start coding. I think that is, I think that's a given for any study that requires coding data. You need to, if not know what the data says beforehand. You need to at least have a sense of what you are trying to code and why you're trying to code, and then that makes and that will help and establish the rigor and the transparency of the research that you're trying to conduct. So, but thank you for the comment and question, Matthew Hill. Vigdis Valger asked, does the number of links between codes within the network assist with any further interpretation of the data, or is it mainly for overview purposes?
I think when you have a basically in a network, when you have a code, or in fact in the context of quantitative research, a variable with multiple connections with other codes, certainly that code plays a very important role in your model. It's because it can transmit the effect of different codes to other codes. So obviously one way to conclude that a code could be an important code in a network is the number of connections it has with other codes within that particular network. So this way you can even see which for example, if you have maybe two mediators or two codes that serve as mediators in a model, in a theoretical model, if the number of relationships that one of them has with other codes is more than the other one, then that mediator plays a more important role in that particular developed model in ATLAS.ti.
Very good. Very good. Yeah, and I particularly find, especially for theory development, when you're doing an inductive analysis and you're trying to develop relationships between codes, the links are really important as an illustrative tool. And yeah, I think the level of density can help assist with the further interpretation of the data, and especially in developing a theory. So a quick comment from Joshua Bianchia. I developed a model for educational outcomes from a project aimed at reducing FGM in Uganda. I relied on dominant categories and developed a network diagram. This presentation is timely for me to strengthen it into a traceable model using the co-occurrence table. Kudos. So,
okay, thank you so much. Thank you so much.
Absolutely. Yeah, no, hopefully this webinar has been useful for all of you who are developing your research. Vinutha Ravinagaswaran has a question, probably similar, probably related to Matthew Hill's question. Do the quotations have to be completely same or similar, or can some overlap be sufficient to infer relationships? This goes to the co-occurrence tool, as in, do they need to occupy the same quotation, or do they have to overlap? If they overlap, go ahead.
I got sorry. I think when we say that the same quotation, obviously it's a kind of, it could be a kind of subjective assessment as well. So I mean, when you have two quotations, when we have two quotations and the amount of the overlap is too much, and when you look at the content, the actual content that is important for us, and you can see that, for example, that the content, the overlap content, really communicating the same message. I think it's a good idea that you just resize the quotation to ensure that you have both of the codes being assigned to the same quotation. In this way, when you select the use AND operator in the code co-occurrence table, it works perfectly. So I think maybe one good strategy is that before we start analyzing the data using code co-occurrence table, it will be a good idea to overview the quotations and understand to what extent some of the overlapping quotations in fact overlap, and whether they can be they can be assigned, they can be coded with the same codes or not. So if we screen this, Even in quantitative research, screening the data before doing the main analysis is very important. So if we screen everything to make sure that to what extent some quotations overlap, and whether we can consider those quotations as one quotation being coded with two quotes, I think that that really helps to come up with a better model as a result of our qualitative research.
For sure. And if I can, ask one question from me, maybe co-occurrence, code co-occurrence analysis can determine the frequency at which codes overlap or codes co-occur with each other, and that would serve as evidence for relationships between codes. And so are there other, you also mentioned, you mentioned at least twice the phrase strong evidence. So is there anything besides frequencies that constitute strong evidence for theory development?
Thank you very much for this very insightful question. You know, the frequency of the quotations indicate a strong relationship, but in a theory, we are dealing with causal relationships, not two-way relationships, you know? So the frequency of the quotations can only determine a two-way relationship. So we know that there is a relationship, but to determine the direction of causality between two codes, it's important to have some evidence in the data. So, for example, leader affect causes leader satisfaction, or leader satisfaction causes leader affect, you know? So this is very important. If you look at the figurative summary of any theories that are used in social science, you can see that we have one-headed arrows between different variables, which means causal relationship. So this causal relationship can be determined between the codes when you have a strong evidence in the data that you have collected. For example, some people have clearly indicated that this concept can lead to that concept. So you can use that argument to build a causal relationship between the two codes. Also, I myself sometimes consider theoretical explanations that can be used to help me build a causal relationship between two codes, even though I'm doing qualitative research. But normally, you know, if there are some established theories that can indicate any causality between the codes, I try to base my discussions based on those theories as well.
Absolutely. Well, it's especially with qualitative research, it's a multi-pronged issue, and you have to look at the data and look at the analysis in different ways. I think that's going to be all the time that we have for questions, and we want to respect everyone's time, and especially the time of the presenter. Dr. Ghasemy, a very insightful discussion, very practical for those who are getting into ATLAS.ti and into qualitative research. I want to really thank you so much for your presentation, and we want to thank all of you for attending this IQRN webinar. We have another webinar coming up next month from Paul Mijas. For more information, check out the IQRN website or the ATLAS.ti website. Remember that registration for all of our webinars for the IQRN webinar series are free. So please feel free to join us for further discussions of qualitative research. For Dr. Majid Ghasemy and for Eric Lee at UBC, my name is Roel Sybing, Senior Trainer at ATLAS.ti. I want to thank you all for joining this webinar from the International Qualitative Research Network. Thank you very much.